For our problem situation, we have the case of a used car dealer that wants to predict the selling price of a Camaro brand car. 31 data were collected on the sale prices of the cars, taking into account variables such as age, mileage, in thousands, condition, poor, average, or excellent, and if the car had only one owner. So we're going to analyze in different ways the relation that exists between our different variables, and we're going to do this by using linear regression and multiple regression.
Regression analysis quantify the relationship between the sale price and the variables. In the analysis, the data revealed a clear nonlinear decreasing trend. Both linear and logarithmic models were evaluated, with the logarithmic providing a better fit to the data. The coefficient of determination for this logarithmic model is 0.86. This value indicates that approximately 86.89% of the variability in sale price can be explained by the vehicle's age. The preference for this logarithmic model over a linear model is justified by its superior explanatory power. To find the best fitting regression model, we gotta find out the R-squared. The R-squared is 0.76 when we use linear regression. That's why logarithmic is the best case in this exercise.
Okay, so the second part is a scatter plot for mileage risk price. A similar analysis was conducted for vehicle mileage as a predictor of sale price. The scatter plot also showed a decreasing of linear relationship as with age. Logarithmic regression model proved to be the most suitable. The equation for the logarithmic regression model is that y equals to minus 67.57 log x plus 888.94, where y is the sale price and x2 is the mileage in thousands of miles, and r squared for this model is 0.807. This means that 80.7% of the variability in sale price is attributable to mileage, confirming a strong inverse relationship. High mileage correlates with a lower expected sale price, same as in the other one in R squared is closer to 1 when we use the logarithmic regression again. That's why it's the best solution. R squared equals to 807. Although the variability is strong as the low being 0.807, there is some limiting factor for both of the regression lines, as there are other variables influencing the price. So in our data, might be a direct relation with the age of the mileage. But more relevant for an accurate regression model, we gotta take account the more variables possible that are influencing the system. Therefore, the actual one variable regression models are not going to be the most accurate.
To capture the combined influence of multiple variables, multiple regression models are added in the report. This model uses age as x1 and mileage as x2 as the variables for the prediction system. The resulting linear equation for price is the following. This model yielded an R-squared of 0.81. This value will represent an important percentage to the variability in the sale price of the used Camaro cars, specifically 81.12. Taking into account the factors of age and mileage combined, since the percentage representing variance is quite big, the results suggest that there is a relevant relationship between the predictions and the results, which in this case is the price.
In the case of our last multiple linear regression, we consider that this is adequate because, first of all, we must remember that in all of our four variables, age is x1, mileage is x2, average condition is x3, and one owner is x4. And our model equation is the next one. And also we have to remember that in all of our regressions, price is y. And we know that this one is adequate because our determination coefficient is near 1, because the value is 0.86, so we can say that it is adequate. And lastly, to know if our variables are linearly related to the price, we use the t-test, in which we can see that the ones that are age, mileage, and the one owner, they are linearly related because they fall in the zone of our 0.05, but the average condition doesn't. And also in the confidence intervals, we know with a 95% of probability that the slope of all of our variables is between those confidence intervals.